Wow, the morning crowd. Thank you so much for coming. Yeah, welcome everyone. Hope you've been having a good conference so far. I always love coming to DroidCon SF. I mean, partially because I'm local and I don't have to travel, uh, but yeah, I mean, I have a couple things to cover, so I'm just gonna get like right into it. My name's Rikin. I am an Android developer, obviously, and most recently I've been, at Pinterest. I worked at Peloton. I've done a lot of Android engineering things in my life, but what's really been interesting to me is kind of like UI techniques for Android. And today we're just going to be talking about one interesting one, which is using shaders for your UI components. But just before I get into that, I mentioned I like kind of experimenting with UI. So here's a kind of overwhelming slide of like a lot of different things that I've been working on that I kind of found interesting. I've been building a lot of cool things, a lot of things with like animation techniques, and I really find it just like fun to just like play around and like kind of like push the boundaries of what we can do with Android apps. But really like the purpose of this talk is to kind of get you all up to speed on what's currently available in the realm of like shaders. What are AGSL shaders? How can I even use that for my Android apps? So just moving right along. So just to like give you a very probably incomplete agenda of what we are going to be covering today, I'm going to give you a really, really quick intro into shaders, like what they are. If you attended Tasha's talk yesterday, she also gave like a really, really good intro. But I'll cover like what they are. I'll cover AGSL and how we can use AGSL with Compose UI. And then we'll get into some examples, and I'll showcase some of the ways that we can use AGSL and showcase some of the ways that we can leverage shaders. And speaking of examples, they're going to be kind of like in two realms here. I do actually believe there are some practical use cases for using shaders, and so I will cover those. And then the rest of the examples I'm going to be going over can be classified as kind of out there. I don't know if you would necessarily use it for your apps or want to use it right away, but I do think it showcases like the power that's available with shaders. So like maybe if anything, it'll just inspire you to build something. So let's just get into it. So a shader, and in our case, we're going to be talking about fragment shaders, which basically they are a program that takes in a pixel coordinate of the canvas that you're giving it. And for each pixel coordinate, it just returns a color. So in this example here, to render this blue square, at that coordinate 50/50, essentially you can think of it as a program that takes in that coordinate and returns the color blue. And for all of the pixels on this particular canvas, it's going to run that same program in parallel to render this blue square. But unfortunately, shader code isn't really written in Kotlin. And in fact, if you've ever kind of like looked at shaders and kind of explored what's possible with shaders, you might look at code like this, which I don't know about you, but I have no idea what's going on here. And it's a combination of single letter variable names and a lot of math that I've either never learned or long since forgotten. So I think this is one of the reasons why people kind of like shy away from like learning about shaders, is because there aren't really a lot of good resources. And if you kind of venture into it, it just kind of feels like this walled garden of like, oh, I'm just not smart enough to do these things. But I promise you, my examples are not going to be that complicated, mostly because I don't know how to build those things. But there are some really cool things you can do with just some really basic shaders. So let's just dive into our first shader, and I'll kind of demonstrate it using AGSL. So this is what AGSL code actually looks like. The first thing you'll notice is that there's semicolons. You do need those again, actually. And in fact, like 90% of the issues that you'll run into are probably because you forgot to put a semicolon, which is very frustrating. Just kind of reading it top down, you'll see the first line says like uniform float 2 resolution. A uniform is essentially like an input for our shader, and this is something that we can kind of control dynamically. So we're going to be, when we set up our shader, we'll pass that information in. You're seeing like all these float 2, half 4 types, and those are essentially n-dimensional vectors or tuples. And like the difference between like float and half is just the level of precision. So half is like a medium precision float, whereas float is a high precision float. It's kind of like the difference between like float and double. And then so you'll see this main function, and that's actually like the core of your shader. That's the function that's running to actually render what you're seeing on the screen. And you can see it's given a coordinate, so that's the pixel coordinate as a float 2. And the first thing that we're doing here is we are dividing that coordinate by the resolution. And this is a process called like normalizing that coordinate so that we can basically put it within the range of 0 to 1. And this is actually kind of like a key point here, is that when you're working with shaders and you look at shaders, we kind of like to work in that value range between 0 and 1 because when we are actually rendering colors, a color is going to be a 4-dimensional vector. Each one of the it's going to be the red, green, and blue channel and the alpha channel. And all of those take in a value between 0 and 1 to actually render the color and at the alpha that we want. So this is like kind of like the magical range. And it also has a very interesting property where we can multiply two things that range between values and range between these two values, 0 and 1, and it'll also be, the result will be something that ranges in between that value. So a lot of shaders are just kind of like combining functions and things that live within this kind of realm. So again, just going back to the shader, the last part is it's returning a color. And the way that I'm rendering this color is I'm actually mapping the x coordinate to the red channel, the y coordinate to the blue channel, or the green channel, and I'm just setting the blue channel to 1 and the alpha to 1. And so this is what is rendering this square right here. And this kind of demonstrates the coordinate space for AGSL shaders, where 0, 0 is at the top left, and that's when both x and y are 0, so you see blue. And then 1, 1 is at the bottom right. So when all of the values are 1, you see white. And just to kind of actualize this in Compose, the way that we actually write the shader is in Compose is as a raw string. Now you can annotate that string with this language annotation and specify that it's AGSL, and then it'll kind of the IDE will magically add some syntax highlighting, but that's kind of about it. Unfortunately, there's no like LSP running for code completion, so it's not going to be the same developer experience you're used to, but this is how we currently have to use shaders with Android. So yeah, like I mentioned, your shader code is going to be as a string. So there's a lot of interesting there's a lot of interesting things that we can do with that information. If we do want to like be a little bit smart on like how we kind of like construct our shaders, like let's say, for example, I want to have some utilities for AGSL in kind of like a separate chunk, then I can actually just write out all of those pieces as separate raw strings, and then I can just use Kotlin string interpolation, and then kind of just pull those in as like pseudo imports for my shader. So these are the kind kind of the techniques that I've been leveraging as things have been getting more complex. Now, as we go over the examples, there's kind of two main ways that we're going to be leveraging shaders for our composables. One of them will be via shader brush, and so this is essentially any component that can take a brush to help paint it can actually use a shader. So we can just pass our shader to a shader brush, and that will be used to help paint that composable. And then the other option is to use a render effect, and I'll kind of get into that when we dive into that example. All right, so I think now we can just start diving in. The first one I want to go over is gradients. I've been really into these kind of like noisy, grainy texture gradients that I've been seeing all around in graphic design recently. Even in like the Material 3 graphic designs, they're using these all over the place, and I think they look really cool. And I just like wanted to see how we can kind of bring those into Android. And so naturally, I was thinking, why don't we try building that with a shader? Before we get into that, the prior art is that we do have gradients already available to us in Compose, and actually under the hood, they are actually powered by shaders. But the high-level APIs available to us don't really give us a lot in the ways of like customization. So I think let's just try and get a little bit closer to the metal. So let's just build up this shader and see like what it takes to build that linear gradient again. So we're kind of starting out with the same code that you saw before. We have this main function. We're given a coordinate. We're going to normalize that coordinate because we want to work in that magical realm between 0 and 1. And then I'm going to create this like interpolation function, and you'll see how I'm using that in a minute. But right now, this is just going to represent the x value. And so we're going to use that to help drive the transition between the two colors. And then all that's left to do is to actually create our color. And we're doing this with one of the built-in functions called mix, which just kind of allows you to interpolate between two values. And so I'm passing it the two colors that we want to create, that we want to use for our gradient, and then I'm passing it in that interpolated value, and then we're just returning that color, and we have our linear gradient. And I'm calling it a linear gradient because the function that's driving that transition is a linear function. It's just y equals x, and if we were to plot that, this is what that would look like. But what if I wanted to get a little bit fancier than that? I hear like easing functions are all the rage these days. So instead of a linear gradient, what if I change this to this smooth step function? Now this is essentially a way to actually ease between two values. So we give it 2 control points, and in this case, I'm just giving it the entire range that we're working with, which is between 0 and 1. So because all of our values lie between this range, we are essentially just going to have this like ease in, ease out curve between these two values, and we're going to use that to instead of our linear function before. And if personally, I can't really see the difference that much. I don't know if you can, but if there are any designers in the room, they would be able to see this immediately. And just to kind of demonstrate, again, like this is the kind of difference that's happening. Instead of just like a linear interpolation, we're now kind of like slowly easing in, kind of speeding up in the middle, and then slowly easing out. So you might be able to see like there's a little bit more of a distinction between the colors. But what if I didn't want to stop there? I'm in a shader, so I have like full control over how I want this to look. So if I wanted to get a little bit crazy, instead of just having one interpolation function for like all the colors, I could theoretically have a different interpolation function for each color channel. So in this example, I'm using that smooth step function for the red color channel. I'm using a sine function for the green channel, and then I'm just using an exponential function and using x squared for the blue channel. And you can see that we get a lot of interesting effects. A lot of colors are now present that weren't really in the original. And we have something that looks a lot more interesting. Now, albeit this might not be exactly what you want, but it is something that is cool, and you do have control over how you want. You have really fine-grained control over how you want like your gradient to look in this case. And if we were to map again, show how each color channel is interpolating, how we're interpolating between these two colors, you can see that now each color is kind of has its own interpolation function, and it produces a much more interesting result. But the whole reason I kind of wanted to get into this was I wanted to create that noisy effect, or that grainy effect for our gradients. And so in order to do that, I'm using a well-known noise function. It's kind of obtuse and hard to understand, but essentially it generates something that looks like this, which is kind of like TV static. And so all that's left to do is to apply that noise function and mix that with our original color. And I just gave it a static value for now of around 0.3 to blend it and bias towards the actual gradient colors, and you achieve a pretty cool effect. So now comparing that to our original, I think that what we created is a lot more depth and is much more interesting, and it's because we have a lot more control. And just to bring this full circle, how I'm actually rendering this is I am drawing a canvas, and I am just drawing a rectangle, and I'm using our shader that we created as a shader brush for that rectangle. So that's how I'm rendering that square. And I'm setting up some of the inputs by just setting those uniform values in our compose code. And then it just works. All right, so that's one example down. The next example I kind of want to talk about is this concept of applying media effects using shaders. And one effect that I thought was really cool to demonstrate was one called chromatic aberration. It's a really fancy name. It essentially is just this effect where the color channels kind of bleed out a little bit and creates this glitchy effect. This is my nephew, Yuvan, by the way. He's very cute, so I wanted to add him to the slides in some way. So he's going to be how we demonstrate this effect. So to kind of to showcase how this is built, we're going to build it with shaders again, and this is kind of the code that's helping drive this effect. And the first thing you might notice is that there's a uniform at the top that is a type shader. Now, the interesting thing here is that we can actually pass in other shaders to our own shader code and then leverage those to create whatever effect we want. And so in this case, we're passing in the image itself as a shader, and then we can leverage that to help create our effect. So what we're doing here is we want to essentially apply an offset to the red and blue color channels. So I'm just setting up a shift, and I'm setting it to 20 as an arbitrary value, and then I'm grabbing the color from our image shader, just to set up our base color palette. And then I'm just calculating two offsets across the x-axis. For red, I'm just subtracting that shift to the x-coordinate, and for blue, I'm just adding that shift to the x-coordinate. And then I'm just updating the red and blue color channels, and then I'm just returning that color, and now we have that effect. And then again, this is kind of where render effects come into play. If we want to pass in our composable itself as a shader for our custom shader code. One way to do that is to use it as to use a render effect. And so here I'm just creating an image. I'm opening up the graphics layer modifier, and I am creating a new render effect using this render effect.create runtime shader effect. I am passing in that shader, and then the name that I'm passing in will be the name of the input for our custom shader. So going back, we've set it up and it works. But what if I wanted to hook up the aberration effect to a gesture or a scroll or something? Well, in order to do that, I'd have to kind of push that up into an input so that we can control it in compose land. So I just move the shift up as a uniform. And then in our compose code, we can just pass in that value however we want. In this case, I am just rigging it up to a slider here. I created the shift state. I'm passing that into our shader, and then I'm having that slider help control the values. And then you can see that now I can kind of play around with the effect until I get something that I like. And I think this is also kind of like a key point, especially when I was playing around with shaders, is adding controls to your UI to be able to play around with different parameters for your shaders, or really anything that you are experimenting with is kind of powerful. So just in this case, I rigged up the shift to a slider, but in other cases, I just have different inputs to kind of help play around with things very quickly. So I think this is just something that you should consider. And then I just wanted to go over some of the examples that I was able to create using this exact technique. So the first one is kind of like a view pager effect, where the aberration, the shift is driven by the page offset of the view pager. Of a particular view pager page, and then in the second example on the right, I'm actually driving it via a drag gesture, and the distance from the center. And the interesting thing here, if this video does play, it might not play a lot, but with render effects, you can actually apply a render effect to any composable. So for example, I have this app here, and I want to apply the render effect to the entire screen. And I can do that just by applying that same exact shader as our render effect to the root composable that's driving the screen. And you can see that it actually affects everything that's within that composition. So I've successfully made the screen a lot harder to read. All right, so I've covered a lot of the practical examples. I'm going to start getting into some things that are kind of out there, but I think that they're still really cool to look at, and I think that hopefully they'll inspire you to at least start taking a look at what we can do with shaders. So the first one is actually this glow effect that I created using shaders, and the power behind this is I'm using this thing called assign distance function. It's kind of a fancy way of just saying they're determining whether a particular point or a coordinate is within a shape. So if the way that you can think about this is that we are using a assign distance function to create a round rect. And then the shader is just determining if a particular point is within the round rect, then we are going to just render the button. If it's not, then I am using some function to help determine what the color value should be. And that color value kind of fades based on the distance they are away from the closest edge. So I'm really into these kind of neon style effects, and I wanted to see how we can kind of use that in Android, and honestly, it looks pretty cool. I don't know how practical it is, but I'll probably be trying to shove this in an app somewhere. And then I kind of started to kind of explore, what else is out there, and I started looking at the site called Shader Toy, which I showed you the code, that really like confusing code in the beginning. But they have a lot of really cool examples, and it's honestly not too bad to like take that code and port it over to AGSL, because AGSL is essentially like a superset of GLSL. So you can actually take that code and almost copy and paste it, and sometimes it'll just work. In this case, it did take some updates, but I was really into all the weather effects that I was seeing on Shader Toy, and I kind of wanted to like get inspired, and I was thinking maybe maybe we can port these over to Android for like a weather application or something like that, because the effects actually look quite realistic. This looks a lot like snow to me, and I was hard pressed to see like how I would emulate this without shaders. Like you could potentially use Canvas, and again there are a lot of like other ways that you can do this, but I think that shaders make this like really accessible. And then I was thinking, I wanted to go kind of really crazy, and I was thinking, what if instead of a normal like ripple effect, we added sparkles to it? So I don't know if you remember when Android 12 first came out, the default ripple was changed into this exact effect. And the funny thing is that the way that they created that effect was by using shaders. So I was actually able to kind of like dig up that code, because I don't think that it's really used as much anymore, because it's pretty poorly received. But it was a shader, and I was able to kind of port that over to AGSL and recreate it just so that we can relive that glorious moment in Android history. So let's just kind of like take stock here and see kind of what we've accomplished. We've kind of created a lot of pretty cool effects, and effects that I feel like hopefully showcase kind of like the power that is available to you if you're trying to use shaders. And I don't think some of them are, too out there. Now, there is an elephant in the room that I didn't really address, which is that in order to leverage this, you do have to be targeting API 33 or greater, which might be a problem for some people, but I don't think that should stop you from, at the very least, experimenting. And there are, as far as I know, there are some efforts being done to kind of help bridge this, because you can already use shaders pre API 33 using OpenGL and GLSL and surface views. It's not as ergonomic as this, but hopefully this is kind of showcasing what's possible. And I kind of wanted to kind of close this in some way by saying, like, I think that it's really fun to kind of explore different UI techniques, and I think that kind of opens your perspective into like what's possible for Android UIs. So I just wanted to like close this out with just some takeaways that I think we should leave this with. The first one is to just know your tools. So I think it's important to kind of know that these things are available to you. And even if you don't quite understand how they work, if you just take some time to kind of like learn, maybe there is an opportunity for you to leverage it. Maybe your designer comes to you and shows you some really cool iOS designs and wants you to recreate those. And it's not as straightforward in Android. Maybe you just need to be a little bit more creative. And so I think it is important to just kind of like know what's available to you as UI developers. And I also wanted to say that there is room for fun and whimsy in like your applications. Honestly, some of the best kind of apps that I've seen usually have like some aspect of like fun, or they some aspect of fun in their user experience. And I noticed that that level of polish kind of emanates throughout the rest of their app. So like if you have engineers that are willing to go the extra mile and build some of these interactions that might not be super easy, that level of effort kind of translates, I feel like, to the rest of their application. And lastly, just, I like to think that, you all are here for maybe one of two reasons. Maybe you're here because your employer paid for the ticket and it's 2 days off of work, which is a completely valid reason to be here. But maybe you're here because you want to learn. You want to learn new techniques, and you want to see how we can push Android forward. And I honestly think that this is one of the ways we can do it, kind of like pushing the boundaries of what's possible for Android UI. So if you want to kind of get started, I do have a YouTube channel. I do talk about a lot of UI techniques, and I have started making some videos on shaders if that's one of the ways you like to learn. I also wanted to call out Tasha Ramesh's GitHub repo. She created one for kind of like a shader playground called Shady. It's also an app that you can install on your phone, but it's really cool. You should definitely check it out. I also had like a repo that I was going to share, but hers is just much better than mine. So you should definitely just use that if you wanted to get your feet wet. And then the last plug that I have is that I've been kind of in the weeds here, and I've been learning a lot. And one thing I've noticed is that there are not that many good learning resources for these types of things. And so I've been compiling everything that I've been learning about shaders, and I wanted to release it in some like form factor, whether that's like a course or a series of articles or a book or whatnot. So I'm just like sharing a little form in case you're interested or want to hear more about it. And this will essentially be something that I'll be working on over the next few weeks, and hopefully, we'll be releasing it to get people started on like how to even like go about learning shaders, how to apply it to UI, and I'll go over some of those examples and more, hopefully, in more detail. And then lastly, if you just need any like UI help, I'm available. This is kind of like the stuff that I'm really interested right now, so feel free to email me at my email, me@rikin.co. Feel free to reach out to me on Twitter, which I'm still unfortunately on. Or feel free to just come up to me in the conference and chat about UI things. I'm available till the end of the day. So yeah, that's it from me.